Dear student, welcome to this session. In this session of lab program number 15, we are going to talk about implementation or implement recursive functions for binary to decimal conversion. So what we have to do in this particular lab program is we are going to implement a recursive function, and what is the program that has to need to do is convert binary number into a decimal number. First, we will understand what is a recursive function. We already know the regular function. What is a regular function? Regular function is a sub code, a small piece of code which is written to carry out a particular task. So that is a function which has which will take it might or may not take a parameter, or it might or may not return a value. So it is a very small piece of code that is written so that we can have one particular task written in one particular function, so that it can be made independent, and also the program will become more modular. Means the program will become very easy to understand. For example, in the math library we have a square root function, right? So that square root function, it is going to calculate the square root. It is kept as a separate function. So in the main program we are just going to call sqrt. So we will not have all the code required to calculate the square root. So that is how the amount of the code or the line of code also decreases. And what is a recursive function? The function which calls itself is called as a recursive function. A function which calls itself is called as a recursive function. The main important characteristic of a recursive functions is, first thing is it will call itself. Means inside the function definition there will be a function call. It will call itself. And also another important characteristic is there will be some kind of a exit criteria. Okay, what is the exit criteria? A function calling itself, it kind of a infinite loop, right? The function will call itself, and again that function will call itself, again that particular function will call itself. This is a never ending, so it goes on an infinite loop. So every recursive function has a one exit criteria from where it will start returning the value to the previous function call. So those are called as a recursive function. Next, binary to decimal number. We know that a number can be represented in a binary number system or a decimal number system. So binary numbers are represented in zeros, ones, and decimal numbers are represented in 0 to 9. And binary numbers we call to the numbers with the base of 2, and decimal numbers are with the base of 10. So first we will see how to do that conversion before getting into the program. How to convert to a decimal number, any number. Let us say a given number is 1011. Okay, this is the decimal number. Okay, so we have taken the example n is equal to 1011 to the base 2, means it's a binary number. How to convert? What is the meaning of this? What is the equivalent of this in the decimal number? How it is done is, so we are going to write 1011. This bit is called as a least significant bit, LSB, and this is called as the MSB, most significant bit. Now what we are going to do is, every bit starting from least significant bit, we are going to have a multiplier with that 2 raised to 0, and the power is going to be increased as we move from LSB to MSB. So initially I have 2 raised to 0, then next bit 2 raised to 1, next bit 2 raised to 2, next bit 2 raised to 3, and we are going to multiply the respective binary bit with this value, right? So what would be the decimal number equivalent? How it will be represented is 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. Now this 2 raised to 3 is 8, 2 raised to 2 is 4, 2 raised to 1 is 2, 2 raised to 0 is 1. Anything raised to 0 is 1. So 1 into 8 is 8, then 0 into 4 is 0, plus 1 into 2 is 2, plus 1 into 1 is 1. So 8 plus 2 plus 1, we get it as 11 to the base 10. So the binary number 1011 is represented as 11 in a decimal number system. Our program is going to do this conversion, but we are going to use not a regular function, we are going to use a recursive function. Now we will go through the program and we will try to understand. Okay, the program is very small, but you need to understand because there is a recursive calls. You have to be very careful how each call is made, how each call returns the value to its previous call. Okay, let us start. First line, hash include stdio.h. Meaning of this is this particular statement includes standard input output header file. Then we have the recursive function declaration, the recursive function declaration, recursive function call, and recursive function definition. It is exactly same as the regular function declaration, call, and definition. There is no difference at all. Only difference is in the definition of the recursive function there will be call to itself. That is the only thing. Other than that, there is no difference between the regular functions and the recursive function. So we have integer data type, integer data type. This is the return value of this function. Name of the function is bin to decimal, and it takes one parameter, that is a binary number, BINNUM, binary number. That is how the name is given for the variable, and it is of a integer type. This also returns a integer and followed by a semicolon. This forms the declaration of this function. Then we start with the main method with a pair of parentheses, open curly brace and closing curly brace. This is the start of the program and this is the end of the program. We have two variables declared here. One is binary number, bin num, binary number, comma decimal number, decnum. Both are integer type, and we will prompt the user to enter a binary number first. So using the scanf function, we are going to read the binary number. So format specifier is %d, and we will give the ampersand BINNUM, that is a binary number. So whatever the user gives, that will be stored in this variable, binary number variable. Now here one assumption is we are expecting users to enter only the binary number. So that doesn't mean that we cannot write a code to check whether what user has entered is a binary number or not. For example, user can enter any number here. User can enter 235 or any number which is not a binary number. If you want to do that, we have to do additional coding to check all the digits are either 0 or 1. Okay, that is additional programming. Here we are assuming user will give only the binary numbers. That means user will give only in terms of 1 and 0, 1010 or 101 or 11, whatever the only only binary numbers he is going to give. Now what we will do is decimal number is equal to, this is the function call, bin to decimal, that is the name of the function. This is the function call, and whatever user has given, we are passing it. Let us say user gives 1011. If user gives whatever the example we just took, we will stick with this. We will understand 1011. User, this binary number value is 1011. We call this bin to decimal with 1011, and when this call happens, the control will transfer from here to the function. So the function will be called here, the control will come here. Now what is the value of this? This value is 1011. That is what we gave to the function. The function is called. Inside the function I have two variables, temp and decimal value. Whatever the decimal value calculated, I have variable. First thing what we will do is we will calculate temp. Temp is equal to binary number divided by 10. So what is the number we have given here? 1011. 1011 divided by 10. What is 1011 divided by 10? 101.1. Since it is an integer, 0.1 is discarded. So what is left? 101. 101 is left in temp. If temp is equal to 0, but temp value is 101, so this is not equal. So this condition is false. So it will not execute this return statement. Then it will come, execution will come here. Now decimal value is equal to binary number modulus 10. And if you remember, what does the modulus calculate? Modulus finds the remainder. What is the value of binary number? 1011, isn't it? 1011 modulus 10, we end up with 1. 1011 modulus 10 is 1. So if you see, we have taken the modulus of this 1011 modulus 10, means we get the LSB, least significant bit we obtain. So this value would be 1 plus, again we are calling binary to decimal. This is the characteristic of a recursive function. Inside the body of the function, there will be call to itself. Now we are calling the function again bin to decimal, and we are passing binary number divided by 10. What is the binary number we have? 1011 divided by 10. What is 1011 divided by 10? It is 101. Now this function is called again with the value. Now what happens? From here, control will again pass to the next function call, that is bin to decimal with the value of 101, and the calculation will happen so on and on and on. Okay, the next it will become 101. After that, again in that particular call it will become 10, and at the end the last call would be with the value of 1. Okay, when the binary number value is 1, temporary value will 1 divided by 10, this will become 0. When it becomes 0, this if temp is equal to 0, 0 is equal to 0, true. When we come to the most significant bit, this if condition becomes true, and we return what was the value? 1. We return 1. Whom do we return that? The previous call. So every call will like that, it will start returning the value, and the final the function which has been called with 1011 will return a number 11 to the main program, and next main program will print the equivalent decimal number is %d and decimal number, and it will stop the program. Okay, now I hope you did not we did not go through all the function calls. We will, in the next diagram, I have put a diagram where we will understand each of those calls starting from the main program. Okay, this is the diagram we have. So here we started with the main program. So some of the code I have not written. Just here, most important is how the control is getting passed and what values are getting passed. That is the first important thing. In the main program, so I will open the main program here. So we did this, enter the binary number, read the binary number, and there is a function call with the 1011. You can see in the main we have some code here. Decimal number is equal to bin to decimal. This is the function call 1011 So this is the first one. Okay, don't get confused with the arrow, just focus on the explanation. So this is the first step. From here we have the first forward call F1. This is the first forward call with a value of 1011. This is the what user has given. With that value I called the function again. I called the function and binary number value is 1011. Inside the function what we have first is temp is equal to binary number divided by 10. I will show you the function. Okay, so here function what we are doing, temp is equal to binary number divided by 10. So binary number is 1011 divided by 10 is 101, and we are checking if this temp value is 0. The temp value is not 0, so it will come here. Now here what we are doing, decimal value binary number modulus 10. What is the binary value? Binary number 1011 modulus 10 is 1, right? The last bit 1, plus binary to decimal bracket 1011 divided by 10. Where we got that? See, we calculated this. Then by dividing the binary number, again I am calling the function. That is what you are seeing here. We are dividing 1011 divided by 10 is how much? 101. The control, this function will not complete. It will not complete its rest of the code. So there is a rest of the code. Even it will not do the multiplication, because the control from here again will get transferred to one more call, that is the step number 3. So from here you can see forward to call. Okay, forward to call with value 101. Binary to decimal is called again with the value 101, and once we are inside that function, again we are going to calculate temp. 101 divided by 10 is 10. So again if condition is there for to check whether this is 0, all those things are not true, again we calculate decimal value is equal to, what is we have here, binary number modulus 10. So 101 modulus 10 is 1, plus binary to decimal, again I am going to call here with 101 divided by 10, that is binary number divided by 10. What is 101 divided by 10? 10. So again the control will go from here to one more next call, that is number 4 next call. This time 101 divided by 10 is 10. We are calling the function with a value of 10. Then we calculate the temp again. Temp is 10 divided by 10, that is equal to 1. Again if condition is there, which is checking whether this temp value is 0. It is not 0, it will calculate the decimal value. And what is there here? Binary number modulus 10. 10 modulus 10 is 0, plus binary to decimal 10 divided by 10. What is 10 divided by 10? 1. Again function, binary to decimal function is getting called with a value of 1. Where we see that? You can see here the function called F4. So I have showed this F4. This function is getting called with the value of binary number as 1. So in this particular function, what happens now? In this function, temp is equal to binary number divided by 10, that is 1 divided by 10, 0. Now this condition, if temp is equal to 0, now temp value is 0. Now this condition becomes true. If this condition becomes true, return binary number. What is the binary number? 1. Rest of the lines will not be executed. This function completes because it's going to return. That is how now you will see the stop of the recursion. Means this is called as a exit criteria. When this temp value becomes 0, then we will start returning the values. So this will return 1. Whom it will return 1? Whoever called this function. And who called this function? This particular place it got the call. So it will return. So this is the return 1 or reverse call. Okay, return 1. And what it will return? 1 value is returned here. Where it is returned? To step number 4. So 1 is returned. Once we get a return value here, 1 into 2, so we have one value here, 0 plus 1 into 2, that is 1 into 2 is 2. We got the value for the decimal value val as 2. Now this function is complete. Now 4 is complete. It will return decimal val. What is the decimal val? Decimal val we calculated 1 into 2 plus 0, that is 2. 2 is returned to who called this, and who called this? It was called in step number 3, that is step number 3, and this is return 2. What it will return? Value 2. Okay, now you can see the value is returned for this particular call as 2. 2 into 2 is 4. 4 plus 1, 5. 5 is stored in decimal val and return decimal val. What is returned? 5 value is returned. And where it will be returned? It will be returned to step number 2, where we got the call for the step number 3. So the return will go like this. You can see here the return will go to, okay, if you didn't realize, R3 return 3, it is coming to this in the step number 2. It was called. And what is returned? 5 is returned. 5 into 2. What is 5 into 2? 10. 10 plus 1. This value is 1. 10 plus 1 is 11. What is stored in des value? 11 is stored. Now the function, this is the return decimal value, and this is the end of this particular function. 11 value is returned. Where it is returned? This function is called by the main method. So this is R4, return 4, where it got call from the main. So this call is Bintu decimal binary number 1011 has a returned value of 11. That 11 value is stored in the decimal number, and that value is printed. Okay, so that is how this program works. If you did not understand, just repeat this particular part of the video, and if there are any question, let me know. Now that is how it works. I will show you the output. So here we will see the output. If I compile the program and execute, then it will ask for a binary number. We give it as a 1011 and equivalent decimal number is printed. Now we'll see the execution of the program. As I told you, we are going to use the JDoodle C online compiler. Already I have entered the program here, you can see. So the program is entered, all the instructions are there, and I am going to run the program. Okay, I will give the value as 1011. Okay, I will run it again. Will take a little bit time. Okay, you get the answer as 11. Suppose if you want to change it to 111, so all ones is 15. Okay, if you want to do 101, we know 101 is 5. Just run the program, it returned 5. So that is how the program works. Now let us see the flow chart. Okay, before we go to the flow chart, a very quick look at the program. Initially we read one number from the user, we call the Bintu decimal function, and in the function first it will divide by 10, and if it is that division is equal to 0, it will return whatever the value was passed. Otherwise it is going to calculate decimal value as binary number modulus 10, plus it is going to call itself by dividing 10, and it will multiply by 2, and at the end it will return the decimal value. Okay, the flow chart, let me open the flow chart. Okay, the main program, we have start, it will read a binary number and it will call a the function. This is called a function call. Decimal number is equal to b into decimal and n. And after that, this function call will return a decimal number and it will display the decimal number and then it will stop. And what is the function call? Okay, binary to decimal function. This is the start of the function with the value of n, and first thing what it will do is it will calculate temp is equal to n divided by 10, and if that value is 0, then it will return the number itself. If this value is not 0, false, then it will make a recursive call. So des value is equal to n modulus 10 plus binary to decimal n divided by 10 into 2. So this actually is another recursive call with the n divided by 10, and that will be keep on calling another recursively. Okay, at the end we will hit a criteria where temp will become 0, then the lastmost call will return the value to the second last call, and so on. They will keep on returning values, and at the end the main function, the first function where it made a recursive call will get the return value, and this return value is given to the main program, and the main program will get a value and it will display.